Hello and welcome to your factoring review video. I'm just going to, from time to time, when we have things that we're really wanting to understand very well, do some videos for kind of my favorite mistakes that I found so that we can learn from them and correct them and move on. In this case, we did a factoring review worksheet and it was broken up into 3 sections, and what I think I'll do is I'll do a video for each section. So the first section said to factor each completely, and I wanted to highlight a common mistake that was made. Not technically a mistake. In fact, on most of your papers I wrote okay but. And the but here is that we typically, when we're factoring, as much as possible, we want to leave our leading coefficient positive, especially when our leading coefficient is positive. So if I take a look at number 3, where it said 16n cubed minus 8n squared minus 14n plus 7, several people actually factored that out as negative 8n squared plus 7 times negative 2n plus 1. And technically that's true. Technically that will get us the product that we have above. The decision making comes when we're doing the area model, and we see that we have a negative, I should say a negative here and here with our area model. And when we're trying to find out, well, what will go into both of these, and we say that 2n goes here and 8n squared goes there, we notice that this 8 is negative, so we tend to want to put a negative there. I get that. Here we see that this 14 is negative, and we tend to want to put a negative there. Really what you want to decide where the negative goes is in the next term. If this term here is positive, let's keep both of these positive. Let's not change those kind of arbitrarily. So then the question becomes, well, then where do the negatives come from? And really, we can decide that on the end, whether we're looking at one that's as complicated as this or just a simple quadratic. You can decide at the end. So again, let's just finish the factoring part. 14 and 7 have a 7 in common, and 8 and 2 and have nothing in common. So when there's nothing, we always put a 1. Okay, so now is when I want to decide what the signs are going to be. Again, my first term is positive, so I'm going to leave both of these as positive. Now, my last term is positive, which means that 1 times 7 has to be the same sign. They're either both going to be positive, positive 1 times positive 7, or negative 1 times negative 7. But in order for me to get a negative in here, this 8n squared has to multiply by a negative 1. And that makes the decision for me. That tells me that this 7 also has to be negative. So that when I end up with my factored form, it is 8n squared minus 7 in parentheses times the quantity of 2n minus 1. We have just enough time for the other issue that I saw in the first group, so bear with me while I find an example of it. Here it is. Something that also cropped up. Really, again, is not a problem. It's not anything that's wrong with the answer. It's just something of notation conventions. By convention, when we have numbers in parentheses like this, a number in parentheses 6a minus 1 times another number in parentheses 3a squared plus 7, just by butting those two parentheses up against each other, we know that they are being multiplied. So when you put that little symbol in there in between them, whether you put an X like that, like we used to do multiplication when we were in elementary school, a number times a number, or you put a dot, those are not necessary by convention. So that answer could just as easily have been written as 3a squared. See, 3a squared plus 7 times 6a minus 1. Don't put the extra symbols in there, because then somebody might think you have an x in your answer, which you do not. So that's that's the most common issue I found in the first set of problems, which were to factor completely. Let's go to the next video to see what's in the second set of problems.